Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Zarif Farhan bin Rusli. Metric number CD190276. This list of my group member. Francis Jalin Anak Luang CD190293 and Muhammad Aizat bin Muhammad Fazil CD190273. We will present about acoustic emission testing. Okay, what is acoustic emission? According ASTM, acoustic emission is referred to the generation of transient elastic wave during the rapid release of energy from localized source within a material. The source of this emission in metal is closely associated with the dislocation, movement, and accompanying plastic deformation and the indication and extension of crack in a structure under stress. Other sources of acoustic emission are melting, phase transformation, thermal stress, cool down cracking, and stress build-up. Okay, what is acoustic emission testing? In terms of acoustic emission testing is referred to the process of detecting and recording acoustic emission using specialized equipment. Acoustic emission testing is a type of non-destructive test entity that has various uses, including ensuring the structural integrity of vessel, monitoring welding quality, and more. The process involves using sensor to detect acoustic emission and then converting the wave into electrical signal so that they can be recorded. We can analyze the result to assess a material condition and locate any detect any defect. The recorded information can provide potentially valuable information about the origin and significance of the defect in structure. Okay, there are several slightly different methods used for acoustic emission, such as global screening, normal during monitoring during normal operating condition, proof test, failure test, and fatigue test. Okay, global screening is one of used method to screen all components and involves by increasing stress level to slightly above normal using thermal or pressure gradient to reveal stress, riser, and crack. Monitoring during normal operating condition is another method involve monitoring known flaws or detecting unknown flaws that can easily be discovered by increasing stress level. Okay, proof test. The goal of a proof test is to show that a given structure can handle load up to certain amount. In this test, we increase the load to the required amount. If success, the test will not recorded any significant emission. Next, failure test. A failure test aims to determine the load at which a structure begin to fail. It involves gradually increase the load into the system begin to record emission that indicate failure in beginning to occur. And last, fatigue test. Fatigue test involve applying a cyclic load to a structure to estimate its working lifetime. Okay, Isaac will continue this presentation. Thank you.
Okay, Assalamualaikum and good evening to Dr. Eliza and my fellow friends. Okay, today I would like to present about the principle of AET, which mean acoustic emission testing. Okay, acoustic emission is the phenomena of the sound and ultrasound wave generation by the material that undergo deformation and fracture process. Okay, is similar with the other type or the other sum of type NDT method, which is ultrasonic, eddy current and magnetic particle, because they're using a same method which is using the wave and electric. Okay, the quantitative and qualitative characteristic of acoustic emission wave generated by the source of the different nature depend directly on the material properties and environment factor. Because the J. Bush and A.J. Brenner have did a experiment. They using a composite material. Okay, in the research topic, which is delamination behavior of composite 2008, in composite material, a signal with a frequency range from between 20 and 100 kilohertz to 1 megakilohertz has been recorded. Because the AE signal arriving at the sensor are affected by the geometry and the wave propagation properties of the material between the sources and the sensor. Okay, this method is used in a number of field, automotive, aerospace, for example, automotive and aerospace, because this method is suitable with the larger structure to be inspected. Okay, this is the method procedure of the acoustic emission testing work. Okay, I said early, I said is suitable with the larger structure. Okay, as you can see, this is in animation. When the structure is larger, so they need more AE sensor to stick with the structure. Okay, acoustic emission testing work by mounting small sensor onto a component under test. Okay, as you can see at this, this figure, they show the point number 1. The sensor convert the stress wave into electric signal, which are related to the acquisition PC processing. Okay, as you can see at the computer data storage post processor, they show they explain what I can say. Yeah, it's more understand when they say is which are related to the acquisition PC processing. Okay, the third point is the wave are captured when the component is submitted to an external stimulus such as high pressure, load or temperature. Okay, as the damage grow in the component, there is a greater release of energy. The rate which is acoustic emission is detected. Okay, acoustic emission can be thought of as a tiny earthquake that occur in the material. The technique globally monitor a component for detect is not allowing for detect but allowing for a defect, allowing a large structure and machine to be monitored while in operation to with minimal disruption. Unlike the disruptive testing, they're using multiple sensor, sensor to what I say is as their source and at the source. Okay, through the signal analysis, the presence of the different source mechanism can also be determined. Okay, there are two AE testing method, which is transient and continuous. The transient method capture the AE burst that exceeds the threshold, which is I can say as the loudness, and they extract the picture as a peak amplitude, like this amplitude. and signal energy and duration of the burst. This feature can be used to assess the condition of the component under test. This method is will suit for the testing structure for defects such as a crack. Okay, the continuous method capture all AE with a side time of period. For example, 1/2 of a second. The feature such as average signal and the root mean square value are then extracted. This method is well suited to application where there is a lot background AE or AE amplitude is low. For example, when testing gearbox or detecting the leaks. The advantage of this method is can be done at a both situation, which is in indoor or outdoor. For example, if we want to inspect the pipe at the site, so we can bring tools, because the tool it can easily and light to bring to whenever they want to be inspect. Okay, next. For example, like I said tadi, it can be done at the both situation, which are indoor or outdoors. For this example, is the outdoor, is acoustic emission sensor. You can see there are leak and corrosion at the underground, which is pipe. I don't think what kind of pipe, but this is example. So there are leak and corrosion, and then they show the sensor which like the previous, but this one is only F2, and then the amplitude. Okay, this one of the leak testing. Leak friction, knot, chemical reaction, check of the size of the magnetic domain are other example of source generating acoustic emission wave. There are some of example what the AET can be test. AET also can be test on in such a metal, concrete or composite, because concrete is same like same meaning as a large structure, because normally concrete is applied to the large structure. Okay, this is example of the how they done the AET process. Okay, for the first example is the pressure vessel test, monitoring and predicting the life of pressure equipment and bundle container. So then the second one is detection and monitoring of structure defect, such as a flaw, delimitation and corrosion. So that's all from me.
Hi everyone, I'm Francis. I will share with you the advantages and limitations of acoustic emission testings. So first, advantages. As compared to conventional inspection methods, the advantages of acoustic emission techniques are: first, high sensitivity; second, early and rapid detections of defects, flow, cracks; third, real-time monitoring; fourth, cost reductions; and then defective area locations. Only critical defects provide sustainable acoustic emissions source. And then minimizations of plants, downtime for inspections, no need for scanning the whole structural surface. And last, minor disturbance of installations. Always keep in mind that cost reductions. What is cost reductions? Cost reductions. The use of acoustic emissions results in considerable reductions in plant maintenance costings, while increasing the available information about plant integrity. Plant downtime for inspections is also minimized. Alright, defects locations. So keep in mind that the AET testings, when more than one sensor are used, acoustic emission source can be located. Thus, the defective area locations is based on the wave propagation principle within the materials and effects by measuring the signal arrival time to each sensor. By comparing the signal arrival time at different sensor, the flow locations can be defined through triangulations. So next, limitations of AT. So the first limitations is, as we note in general, poor repeatability. As you can see in this diagram, A and B. A is for good repeatability and B is for poor repeatability. So in limitation for AET is mostly is poor repeatability. As you can see the dot here at the final analysis graph, it have how to say that, it have gap of the dot. So second, influence of ambient noise and intrusion of signal may result in poor output. And then AE results are set firmly to the knowledge and experience of the service provider. Last, sophisticated data processing devices are required. So this means that in industry, you need a gear or computer that high spec or high specialty and have a great feature to run the simulations, at least 30 gig RAM, something like that. And then despite all the invitations of a testing, we have to clearly point that this AET that is cannot be applied always and everywhere. Defects which are neither growing nor moving do not produce AET and thus cannot be detected. Okay. So what is data processing? So influence of ambient noise and annotation of signal may result in poor output. This means that the importance of data processing. So what is the need for data processing? Importance of data processing includes increased productivity and profits, better decisions, more accurate and reliable. That's all for me. Thank you.